Okay, so in this test portion, 7.1 A, we'll be covering a new chapter starting with chapter 7, which is triangles. Okay, first thing we'll discuss is your SAS congruency. Okay, now in your syllabus this is given as only to motivate. That means students need to just understand the meaning of this congruency condition. Okay, congruency condition. Now just write the statement: two triangles are congruent. Along with me, two triangles are congruent. The word congruent means same in shape and size. Okay, two triangles are congruent if two sides, okay, if two sides and the included angle and the included, the word included here is important. Okay, included angle, that means one angle, okay, are equal to two sides and the included angle, okay, included angle of the other triangle, of another triangle, also you can say of another or other triangle. Okay, then okay, two triangles are congruent if two sides and the included angle are equal to, okay, two sides and the included angle of the other triangle. That will be a better word. I thought two triangles are congruent is at the end. Okay, so there is a better option: included angle of the other triangle. So in order to exactly understand this, let us draw two triangles. You can draw along with me. Just a presumption for us to understand. Let us say this is A, B and C, P, Q and R. Okay, now you see here, let us say this is 5 centimeter, this length AB, which is equal to QR 5 centimeter. Let us say BC is 7 centimeter when you measure the length, and this one is also 7 PR. Now what are the angles between these two, 5 and 7 centimeter, meaning the sides AB and BC? Let's correct this one, right? So let us say this is 50 degree. Now what are the two angles between these two sides, 5 and 7 centimeter length, PR and QR? Yeah, that's right. So this is also equal, let us say 50 degree. So what do we write here? Then we can see the two sides AB is equal to QR 5 centimeter, BC 7 centimeter equal to PR 7 centimeter. Two sides are equal and the angles between them, so the angle should not be here outside of these two, 5 and 7, are equal between these two, 7 and 5. Then the triangles are similar by what? SAS. So we will write here like this. Now this is important in congruent triangles. Triangle ABC, if you were to write like that, ABC. So you went from AB means 5 centimeter length. So you find out the corresponding means. You shouldn't go PQR because PQ is not given as 5, right? QR. So we write just as you start with AB. Congruent sign is equal with a wave sign over QR, and then we went to ABC. So BC is 7. So RP, QRP. If you wrote like this, ABC congruent to triangle PQR, this will be wrong. This is the correct way of writing. Because congruent triangles, similar triangles, the three vertex of the triangle should be corresponding. That means A correspond to B, Q, B to R, looking at the condition given. Okay. So now when we say these two triangles are congruent, we mean to say in simple meaning, the two are exactly same shape, same size. Okay, similar means only the shape can be similar, the size may or may not be equal. Okay, size, yes. But congruent means both sides and shapes should be exactly identical. That's the meaning of congruent figures or congruent triangles. So now when two triangles are congruent, then this will always follow the three angles of the triangle. First letter, angle A. First letter, that is called corresponding angle. We can write in short as CPCT, which means corresponding parts of congruent triangle. They are always equal, okay, whether angles or sides. So since triangle has three sides, the second letter is B here in first triangle. Second letter is, we know this because CPCT, corresponding parts are always equal. Third letter, and here third letter. So you can write along with me. So the corresponding three angles will be equal, and the corresponding three sides, because it has got three sides. Each triangle has got three sides and three angles. So first two letters make the first side AB. Then, oh sorry, we made a mistake. This is the wrong way of writing. Sorry. Go back here. Here see A and Q. This is the wrong way of writing. So Q, B and R. Third letter C and P. Okay. So this I wrote the wrong way also, just to make us understand this is the wrong way of writing. We will not use this. We will use this thick one. First two letters AB. Then first two letters is not PQ. It is QR. They will be equal because CPCT. Not only angles but sides also are corresponding parts. And BC, the second and third letter. Second and third is RP or PR also you can write. You can write RP, PR, that's up to you. Again, like that. Then first and third letter, if I take SC, then here QP. You can write QP or PQ, that's okay. Only thing is, the positions should be corresponding. AB, first two letter. So it can be first, second, or second, first also, it's okay. Okay. Again, this is here. So we must keep this in mind that when two triangles are congruent, the corresponding angles will be equal and the corresponding sides will be equal as well. And we write in short as corresponding angles equal corresponding sides. We write in short as CPCT. The P here denotes parts. The two parts angles, okay, and the other one sides. So that is what we keep. So first condition for testing congruency of triangle is SAS, which says if two sides and the angle between are equal to two sides and the angle between another triangle, those two triangles will be congruent by SAS congruency. Okay, so here next, let us go to the example 1 and apply this SAS. So example 1, textbook, page 124. Okay, open your textbook to that page. So there is a figure given to us, so let us just draw that. Something like this is given, I think. Okay, and then marked as A, D, O, B and C. Then this here equal to this and this equal to this. So let us write them down. Given means in the question given. In the figure, OA equal to OB. It's already given in question, and then OD equal to OC. We have to prove. So first one, number 1, triangle AOD congruent to triangle BOC. Then second one, we have to prove AD is parallel to BC. AD parallel to BC. So here now, let us start the proof, means the answer for this. So let us take the first one in triangles AOD and BOC, which we are trying to prove are congruent. So we just write exactly as it is, and since we have put here S plural, we didn't put another triangle sign there, no need, because S denotes plural there. So second one, okay, proof. Let us first prove this two. First one, So here AO, the first two letters, and first two letters are always corresponding. They are already equal. You can see here OAAO is same. Okay, you can write here since that is given in the question, as you can see here. Next here OD equal to first and third, or second and third, second and third. OC, is that so? I think so. See here OD equal to OC. Now the key is now find the angle between these two sides of this triangle AO OD. Between AO and OD, let us put here angle 1 and this one angle 2. So angle 1 is between these two sides BOOC. BOOC, the angle 2 of this triangle. They are clearly equal because we know they are vertically opposite angles. When two lines cut, these are vertically opposite, just as these two are straight lines. So we see here that the two sides of this triangle are equal to two sides of this triangle, and the angle between these two sides, angle 1, between these two sides, angle 2 are so equal, so the triangle will be congruent, right? So we write here therefore triangle AOD congruent to triangle BOC. Triangle BOC, since using SAS congruency condition, the one we discussed just a moment before this question. Right, so first one is proof. So you can just put this one as equation number 1 and write here your one answer, triangle AOD congruent to triangle BOC. BOC since using equation number 1. Then next here, number 2, let us just use these ones, triangle AOD congruent to triangle BOC we have proved here. Since we are using equation number 1, so this is your first answer. Now again we are repeating to prove the second one. Now let us take here D, the third letter, angle D, this one. Then the third letter, angle C, will be the corresponding angle. Third position is corresponding angle. See here now, D and C are equal now. Why? Because we know that when two triangles are already congruent, then the corresponding angles are equal, corresponding sides are equal. We don't need the sides for this case, so just write angle. And we write just CP, CT, which are nothing but alternate angles. See here, which are alternate angles. These two lines you consider AD and BC. This angle inside right, inside left D. So if the alternate angles are equal, then the lines above and below, or below and above AD parallel to BC. Since we can see alternate angles are already shown to be equal. So this is the second answer. This is the first answer. Okay. One more question before we end this test portion, example 2. So go there, page 125. So these two are simple. We're just starting the chapter 7, triangles, and the specific topic is congruent triangles. Okay. So the first condition we'll discuss, SAS congruency condition. So let us go and do page 125. Figure is given to us, so let's draw here the line like this, and there's a line here right down. Question is saying this is line L, this is P, A, B, and C. Now let us write down. Given to us is, if you read, L is the perpendicular bisector. Question is saying bisector of AB, meaning this L line makes 90 degree, perpendicular means 90 degree to AB, and bisects AB means if this was AB was 10 centimeter, this line will divide them into 5 and 5. So this AC will be equal to BC. The meaning is perpendicular bisector means of AB means AC will be equal to BC, and this is 90 degree, perpendicular means. So we can just start it. Then one more is there. P lies on L. One more point. The point P is lies on the line L. So this is not outside this line, on the line P, which is the vertex of the triangle. We have to prove, so here, to prove is P is equidistant from A and B. P is equidistant from A and B. In other words, the distance of P from A and from B are equal, means this here AP, distance of P from A, equal to BP, BP. The distance of P from B, BP, they are equal, equidistant. These two distances are equal, we have to prove. Let's start it. Let us do it. It's simple, I think. So here, prove the answer for this. Let us take these two triangles in triangles APC. If you go like this for this, then on the right side you should go the same, because in similar and congruent triangles, position of the letters of the vertices of the triangles are very important. You put in right position. So AP, you went like that, then you have to go BP, same style, that's called corresponding BP, C. So in these two triangles, let us say here AC first and third letter equal to BC first and third, because it is given, you can see here clearly here, AC equal BC, right? Then here PC, let us say second and third, is equal to PC, because there is a common side to both these triangles here. PC is the side of APC, and PC is also the side of BPC. So common means they are equal. Then let us find the angle between AC and AP of this triangle. AC and AP, let us say 1. And this one is angle 2. So between this BC and PC, BC and PC is angle 2. Now why are they equal? Because we know each being 90 degree, because we learned that this line is perpendicular, means 90 degree to AB. Now, so we see here again, two sides of the triangle APC are equal to the two sides of the triangle BPC, and the angle between AC and PC, angle 1, angle between BC and PC, the two equal sides, angle 2, are equal, means the triangle APC is congruent to triangle BPC by condition called using Sas congruency. Now we know that if two triangles are congruent, then the corresponding sides are equal, angles are also equal. But we don't need angle here, so let us just find out to prove AP-BP. So first two letters, that is, then corresponding is first two letters in the next triangle. And we know CP, CT. It's okay, right? It's simple, right? So that's how you do it. Now you go and give it a test after going through carefully. Okay, I hope we got it.